Hello, hello, hello. Welcome everyone to the training. I think the system is slowly configuring. So please let me know in the chat where you're watching from today. If you can see me or hear me, because I want to make sure that, oh no, we have some sound issues. Okay. I know that there is an echo. There we go. Okay, that should be better. But okay. Vicky, thank you so much for letting me know that you can see and hear me. Nikki, welcome from Oklahoma City. Thank you so much for being here today. I know that you could be anywhere, and the fact that you are here with me today in our How to Teach Integers training, I am seriously so humbled and I am so grateful to you. I am going to share my screen with you. Welcome, Nikki from Oklahoma City. Oh, Vicky. We got two Vickies in the house. Brittany from Houston, Texas. Welcome. I'm going to share my screen. It's gonna look a little bit crazy for a second. I'm gonna share my Chrome tab. Here we go. Okay. Gonna look a little wild for a second. There we go. Okay. I have another computer next to me so I can see the chat. So if you have questions as we are going through this, please type it in the chat because I want to be able to answer all the questions for you. And yeah, I don't want to waste any more of your time. Again, I'm so thankful you are here. This training should be, I'm going to say about 45 minutes, depending on how much I talk, how many questions there are, because I want you to be able to leave with everything that you need. Welcome, Lana, near Indianapolis, Lindsay from Illinois, Jamie from Arizona. Welcome. Thank you so much again for being here. Truly, it is my honor to be here with you tonight and to kind of just share with you a little bit of my knowledge. So who the heck am I? My name is Kathy Martin. I've been an educator for over 13 years, and I am the proud creator and leader of the Prealgebra Teachers Middle School Math Membership. We serve 6th, 7th, and 8th grade math teachers and Algebra 1 teachers. So if you are already a member of our membership, if you're already a teacher member, you know how amazing it is. This community was created because when I first started teaching, I was given the keys to my classroom and my principal was like, here you go, goodbye and good luck. So I had nobody, I had no resources. So this community, this membership was created because I didn't want to see any other teachers teaching alone. And more importantly, I didn't want to see any other teachers who were like me wasting time and money trying to find quality resources to teach our kids. I was spending hours after school, hours on the weekend finding resources because my textbook from 1971 just wasn't cutting it. So I wanted to create a place where everything is together, all of our 6th, 7th, and 8th grade, and now Algebra 1, things are slowly being rolled out as I create them. I wanted everything to be in one place. And it is truly my honor to lead this group and to serve these teachers who then are serving students. So that is me. I'm so glad you're here. In this training, what you're going to learn today is I'm going to share with you how I provide visual models, specifically counting chips, so that students can see how to add and subtract integers. I'm going to be also sharing with you my easy adding and subtracting integer rules so that when you get to the part of your teaching where you no longer need to use visuals and you can just give them the rules, it's easy for them to remember. And I have students come back to me years later reminding me of the rules. So it's worked, and it's how I've done it for the last 13 years because it works. And then I'm going to share with you some of my favorite activities to use for review and practice so that you can kind of see how all of this, is laid out in action. And hang with me into the end because you're going to be able to grab one of my favorite freebies, which is my integers reference sheet. And it's only going to be given to people who are here live. So if you are ready, give me a yes in the chat. Vicky says, will these ideas be printable or the slideshow, or do we need to take notes? Please take notes. Yes, Vicky, if you're a member of the Prealgebra Teachers Math membership, which you may or may not be, all of the resources I'm going to show you are already inside the membership. So don't worry about that. But yes, if you are, and then this training is going to be inside the membership. So I hope that is helpful. Yes, we got a ton of yeses. Awesome. All right, here we go. I'm so excited to share this with you because I've noticed that, the kids these days, kids are really struggling with this. So I wanted to put together this training just to help all of us teachers make this easier. And the most effective way that I have found with teaching integers is to use counting chips. You don't have to buy anything. You can certainly go to your local hardware store and purchase physical chips, physical manipulatives. But if you're someone like me, you're on a tight budget. I just took, this is a picture on the left here. It's like the red and green. I just took construction paper, cut them up into squares, labeled them plus, and labeled them minus. So I would just make sure if you do this, if you want to use construction paper, just pick the same color for all your positive chips and pick the same color for all your negative chips. And you can use whatever color you want. I just picked green because green to me was like the color of money, and kids can understand money, that money means, like more, or it means it's, you have some. And then red, I don't know, I just picked red because there's no rhyme or reason, but you can pick whatever you want. You could also, like I said, go buy counting chips if you want, but you definitely don't have to. Okay, so how do we use these counting chips to teach integers? And I'm going to, before I even dive in to show you what this all even looks like, I want to just caveat this by saying, when I teach this, even if you've already taught this and you're like, they're still not getting it, and you have to go back and teach it, which is totally fine. I do a lot of examples using the counting chips. And when it gets to the point where you feel like, oh my gosh, the kids are getting bored with the counting chips, most of them kind of get it, like do 10 more because it's not going to hurt them. And especially if they are not getting it, they need to get it because, as you know, like, let's be honest here, integers, if they don't understand integers, you can't do anything else. I mean, you can, but it's going to be really, really hard. Everything else that you teach from here on out, it's going to be really hard. Like distributive property is going to be hard. One-step equations are going to be hard. Multi-step equations is going to be even harder. Like, it's just going to be really, really difficult. So we need to build a really strong foundation with our integer skills so that it just makes their life easier, right? And they can understand the math easier. Okay, so let's dive into adding integers. And you can use digital manipulatives too. These counting chips that I just made here, this is on Google Slides and you can use PowerPoint. I just went into here, insert, shape, and then circle. And I just made it a color. That's it. And then I just made like a whole bunch of them. Okay, so it doesn't need to take a lot. You don't need to be a super tech expert to do this, to be able to visually show your students what this looks like. Okay, so how does this look like when I'm teaching it? So, okay, also before I show you, I want to also mention that before I even dive into adding integers, my students do already have an understanding of absolute value, okay? So your students will have to understand the concept of absolute value, that absolute value means distance from zero, and that, there isn't a negative distance, right? And that's why the absolute value of any number is a positive number because it's just distance from zero. And they need to know this because it's part of the explanation. So I just wanted to tell you that. Okay. So if I am showing my students, right? And you guys are all my students right now. So Vicky, Susan, Brenda, Christine, Brittany, if I was teaching this to you, if you were the kids in my class right now, and we are going through integers, this is what it would look like. So if I had -4 plus 1, I'd pull up 4 negative chips like this. So here's 1, 2, 3, 4. 4 negative chips. And then here's my +1 chip, okay? And so what happens here is, oh, look, these zero out, okay? So these zero out. What do you have left? What do you have left? That's right, -3, okay? So we're going to go through a lot of these examples, lots and lots and lots. And I don't have time in this training to go over all the examples that I would go over in my classroom because, well, you know, you have places to be and things to do. So this is like a super Reader's Digest version of what I do. And I hope you know what Reader's Digest is. Oh, that makes me feel really old. So, okay. So this is example 1. So I'm going to move into the next example. So I have 5 plus -2. So here is my +5, 5 chips. I'm just going to pull them up. Susan says, I teach special education and the general ed teacher did integers last week. Wish I had it last week, but thankfully I have it now. Yes, Susan, it's never too late. You know, and chances are the kids probably need more practice. Okay, so here are my 5 positive chips and here's my 2, right? Okay, so do I have any that zero out? Okay, so these zero out and these zero out. So what do I have left? +3. Okay, so now I'm starting to get the students to, we're doing a lot of examples. I've done 2 here, but really in reality, I probably would do 10 to 15 at least before I start asking, what are you starting to notice? All right, like what are we starting to notice here? And okay, so if I have 3 negatives, right? So 1, 2, 3 negatives, and here's a 1. Okay, so do any of these zero out? Yes. Okay, so this zeroes out with this. So what do you have left? -2. Okay, so I'm starting to notice here that look at 3 is the absolute value of 3, right? 3 is the bigger number. Well, the absolute value of 3, -3, is the bigger number. And my answer is -2. Okay, so I'm starting to notice that in my first example, the larger number with the greater absolute value seems to match the answer with the sign. The sign seems to match, right? -4 is the larger absolute value and it's negative. So my answer is negative. Down here, 5, the absolute value of 5 is larger than the absolute value of -2. 5 is positive, and oh, look, my answer is positive. Same with this last example. The absolute value of -3 is larger than the absolute value of 1, and it's negative, so my answer is negative. So I'm trying to get the kids to start to notice like what is happening. Okay, and now we're going to do some examples to test that. Is that true? Is that true all the time? So let's see. -5. Okay, so I have -5 here. 1, 2, 3, 4, and 5. And then here's my +2. So which number has the greater absolute value? 5, -5, right? So is it safe to assume, without even knowing the answer, is it safe to assume that my answer is going to be negative? Well, let's see. These zero out, these zero out. What do you have left? It is negative. So -3. So maybe there is a thing to this whole absolute value sign. So same here. Okay, so I got 6 negatives, 2, 3, 4, 5, and 6, and I got 1 positive. So which of the 2 numbers has a greater absolute value? -6, right? And 6 is negative. So can I assume that my answer is negative? I think so. So let's just put the negative there just for funsies. And this cancels, or this zeroes out. And what do I have left? 1, 2, 3, 4, 5. Yeah, 5 negatives. This pattern sure is working. Okay, let's try this again. So I got a +2, +2, and -3. Which number has the greater absolute value? -3. My answer probably is going to be a negative, right? I don't know what that number is yet, but it's probably going to be negative. So this zeroes out, this zeroes out, and I'm left with -1. Okay, so that is what happens if I have opposite, like opposite numbers, right? Like a positive adding a negative, right? These are all negative, adding a positive, negative, adding a positive, right? So what happens when you add integers with the same sign? Charlene says, can I use this for my students with disabilities like autism and ADHD? 100,000,000% yes, Charlene. I was a special education teacher for many, many years. Many of my students had autism, ADHD, ADD, like all the things, and this is exactly how I teach them, and it works every time. So I encourage you, Charlene, to definitely use this. Okay, so what happens if we have students? What happens if when we add integers with the same sign? Well, let's see what happens. Okay, so I got a -2. Here's -2 plus a -1. So what do I have here? I have 3 negatives, right? So -3. Okay. Here I have -2 plus a -3. So nothing is zeroing out here. Okay, so I'm just collectively kind of adding them together, right? So I got a -2 and a -3, and my answer is a negative something, a -5. Interesting. Okay, and in this example, I have a -1. Here's -1, and here is -5. So 1, 2, 3, 4, and 5. Again, nothing is going to zero out here. So a negative and a negative, looks like I'm going to get a negative something, right? 1 and 5 looks like it's going to be 6. Okay, so I just want to again remind you, after lots more practice, okay, using visual models, I will show my students how to add integers following the adding integers rule. I'm going to share with you what that is in just a second. But I just, again, want to remind you that I gave you maybe 12 examples here. Please, please, please do a lot more than 12, okay? Your students will need the repetitiveness. If you can cut out the construction paper or purchase physical manipulatives, that makes it even better. But if you only have digital, that's totally fine too. They can visually see how the tiles are like zeroing out, or if we're just adding things all together. Okay, because you don't want to present the rules until they really understand visually how it works. Christine says, I feel like I would be able to do these 2 in one period. Do you do this all in one day? Maybe I rush it, and that is why my students have been having trouble retaining the skills. So I will do this like all period long, okay? And I will give them like maybe some practice problems to use, but using the tools or using the visual models. So we're not talking about the rules. Oh my gosh, bring it back, Kathy. Okay. I don't do the counting chips and the rules in one day usually. Usually I will do it in 2 days because we do a lot of practice with visual models. We do a lot of practice with moving things around, zeroing things out, and then we will do more practice the next day, and then we can talk about the rules. And I definitely introduce adding integers first, then we do subtracting integers, never on the same day. I hope that answers your question, Christine. Okay, so here is the adding integers rule, and it's like a song, okay? You can sing it or you can just say it. So it's same sign, add and keep, different sign, subtract. Take the sign of the bigger absolute value, and your answer will be exact. It's a rhyme, and the kids will remember this. Same sign, add and keep, different sign, subtract, take the sign of the bigger absolute value, and your answer will be exact. So this is like an anchor chart that I made in my classroom, how to add negative numbers. So here are your two rules. Same sign, we add and keep. What does that mean? Well, if there are two negatives, they have the same sign. So we're going to add them. So here in this example, it's -3 plus -5. If we add them up and then keep the negative sign. Yes, it is to row your boat. Exactly. And then different signs subtract. So we're going to initially subtract. In this example on the screen you see here, it's -5 plus 2. So we're going to subtract them. 5 minus 2 is 3. And then we're going to take the sign of the bigger absolute value, which is -5, which then means my answer is -3. Okay? So same sign, add and keep, different sign, subtract, take the sign of the bigger absolute value, and your answer will be exact. Okay, so let's dive into subtracting integers. Again, I do not teach adding integers and subtracting integers on the same day. That's like way too much for their little brains, because we have to have a really, really good understanding of adding integers first, really understanding what visually that looks like, and then we do the rules, and then we move on to subtracting integers. Okay, before I dive into subtracting integers, I'm gonna take a quick sip of water. Okay, so when I teach subtracting integers, I always tell my students, we are never subtracting. I know, their brains are like, right? So we're never subtracting because we never are. So it is something that I have to really instill in them. Yes, the bundle is included in your membership. So definitely yes, Vicky. I tell them I'm lazy and I don't want to subtract. Yes. Exactly. That's totally a great way to put it. I'm lazy. I don't want to subtract. So we're just not subtracting. Or it's like, oh my gosh, guys, I love you guys so much. We don't have to subtract, right? So the way that I teach this is, I'm not going to get into like the whys of it all because that would add another like 20 minutes. So I'm not going to do that. But the rule for subtracting integers is I teach them 3 letters. KAO, keep, add, opposite. That's it. Keep, add, opposite. Is there a way to get a copy of the slides? Jennifer, I'm not including the slides in this. This is just our live training today, and you're here, and so I'm so glad you're here. Amber says we have a quick memorial service for subtraction. I love that. Yes, totally. We send our love and our condolences to subtraction because we're not doing it, right? We are keeping, adding, opposite. And I know that there are other acronyms that other teachers might use, but I use KAO, keep, add, opposite. So this looks like this. So I always do this. I put this at the top, keep, add, opposite, so the kids can see. Okay, so what this looks like is if I give you 7 minus -3, we keep the 7, we change the subtraction to add, and then we take our secondary number, -3, and make it the opposite. So the opposite of -3 becomes +3. So this becomes 7 plus 3, and that is 10, right? So now we are using the rules for adding integers. KFC, keep, change, flip. Exactly. Same exact thing, right? I used to use KFC and I used to bring in like buckets of chicken. And I have like a whole poster board with like KFC, the KFC Colonel Sanders and stuff. Anyway, but okay. So in this example, keep, add, opposite, -5 minus 3. So I keep -5, change my subtraction to an addition, and my +3 becomes -3. And now I have an addition problem here. -5 plus -3. So is this same sign, add and keep, or is this different signs? And this is exactly what I'll ask my students. Is this same sign, add and keep, or is this different signs? And they'll say, oh, same sign. Okay, so let's add and keep. So let's add 8 and then make it keep the negative. Okay. So by subtracting the integers, we are still reviewing our adding integers rules, because by using the keep at opposite or the keep change flip, whatever you want to use, you're still always going back to those adding integer rules. Let's see. Okay, so this example, -8 minus 9. Again, we're going to keep the -9, change your subtraction to an add, and then +8 becomes opposite, so -8. Again, so then is this same sign or is this different? Same sign. Okay, so let's add and keep this. 9 plus 8 is 17. So let's keep and let's make it a -17. Okay, this one, -17 plus or minus -5. We keep our -17, change our subtraction to an add, and the opposite of -5 is +5. So is this same sign or different? Oh, this one's different. Okay, so what are the rules here? Well, I have to subtract, okay, and then I do have to subtract eventually, but we're not subtracting from the get-go. So we have to subtract and then take the sign of the bigger absolute value, right? So 17 plus 5 is -17 plus 5 is going to be -12. Lindsay says, I'm thinking ahead, but KO should continue to work when factoring negative numbers. 100% you can use that to factor negative numbers using distributive property. Nikki, what do you give them as a rationale for turning the problem into addition? I always tell the kids that because when you are subtracting the number, or when you're subtracting integers, you're really taking away, right? So things are getting zeroed out. And I do use the counting chips to show them this, but I will show them afterwards, because I think maybe it's just my own explanation, and maybe I'm not doing a good job. Um, of explaining the why we keep at opposite. So I show them the rules first, because it's all about taking away and things are zeroing out, and it's the zero, what is it called? It's the zero rule. And so it's a little bit confusing for them, but I do show them. I just wait, because I want them to understand like the process first. And honestly, if you sometimes my kids are like, this sounds great. Like, this makes sense. I understand, like, how it all works. So I don't need an explanation. So yes. Suze, do you ever use the number line as another visual? Yes, we do. We have small individual number lines, so each student gets their own with a marker and Kleenex fancy eraser. Yeah, 100%. You can. I also like to use number lines. It's nice for them to like do the moving across the line, showing how things get bigger and smaller. We talk about money a lot with this because kids know money, they love money, and they can understand, if I owe somebody this and I pay a little bit back, how much do I still owe, or how much do I, how much like profit am I getting? So many different ways. I've just found that the the counting chips just really, really works well. I show them using the plus minus tiles, how you can't subtract when you don't have the chips there to take away. So I add in 0. Exactly. They get annoyed quickly, and they want to keep change your KAO. Exactly. Yeah. So, and that's it. That is how I teach adding and subtracting integers here. This is so when once we get both of them together, like once I teach them all, here's the reference sheet that I was talking about, which you'll get a copy of in just a bit. But I hang this up, I give them this. And if you are a member of the Prealgebra math membership, you actually already have this inside the membership. So please feel free to print this, put this up on your wall, and refer to it. So here are some of the things that I use to practice integer activities. Some of my favorite activities are task cards, because the task cards that are inside the membership that I use in my own classroom comes with 15 task cards. And you don't have to use all 15. In fact, I don't really ever use all 15. I might just assign like 5 each day. Or I might have the kids do a handful in a station so that they are continuously practicing. Even if we're like far beyond integers, we are well into learning other things. I will bring back integer activities all the time because it's not going to hurt them to continuously practice these skills, because no matter how far they get right into, you know, algebra 2, calculus, like it all comes back to integers. So task cards, one of my favorite activities. And fun fact, well, I don't know if it's a fun fact, but maybe it's a secret. Your admin loves to see task cards. I'm telling you now. It's just such a great alternative activity to use in class that's not like your textbook or not just like another boring worksheet. It's hands-on, especially if you have students with disabilities. For your students with disabilities especially, and really all students, for them to have just one problem on a card that they're working with, one problem that they're focusing on, it really helps with that anxiety versus giving them a sheet with like 37 problems on it. That's just like all the way down the paper, So I love task cards. I swear by them. And if you are not using them, I highly encourage you to do so. Differentiation, exactly. Homework alternative, classwork alternative, just so many different ways to use task cards. Okay, one of my other favorite activities, coloring pages. This is also inside of our integers bundle. It's great. Again, I love to use this as a homework alternative. There's something so special about assigning a coloring page, because even my too cool for school kids, they'll like sit there and be like, I don't want to do a coloring page. And then you give it to them and it's like, it takes them back to their childhood, and like I know for me as a full-fledged adult, like who's almost 40, like I love to color still, right? It's like so relaxing, and it's the same for them. Small group games. This is an adding, subtracting integer board game that I created. So I like to put kids together in groups of like 4 or 5. They go around the board with their pieces. They go through each question. Vicky says, today coloring page with exponents. Yes, Vicky, during state evals, got a thumbs up. Totally. It's just something so great, like, and just relaxing. I don't know, magical. So my group board games, love this. It brings out the competitive nature. I hate to say it, but it's also just super, super fun too. I love these digital self-correcting activities. We have digital mazes, mystery puzzles, and pixel art. In case you've never seen these, I'm going to see if I can just share this. Will it switch over? Nope. Okay, wait, hold on. I am going to see if I can share the screen with you, because I want you to be able to see what these look like. Okay, I think that should work. All right. So this is what a digital maze looks like. And what I love about this is that it's self-correcting. So like you don't have to grade it. And students get instant feedback as to if they get a problem wrong. So here it says start here, 5 plus negative 10, right? So what is 5 plus negative 10? Okay, so it's different signs. I'm going to subtract, take the sign of the bigger absolute value. So that's going to get me negative 5. So I'm going to show you something super magical that happens. So I'm going to hit enter. Bam, the path lights up to the next problem. Okay, so now I'm going to go here, and let's just say I get it wrong. Let's say I enter 40. I hit enter, and you can see nothing happened. So that's how your students will know, oops, I got it wrong. Okay, let me try again. I think it's negative 43. Okay, bam, right? So now the path continues to light up until they get to the finish line. The other activity that I want to share with you is mystery puzzle. Bam! Oh my gosh. Okay, so I know this just looks like a screen with a bunch of problems, and like this green thing, right? So it's again, self-correcting, so you don't have to grade it. And you don't have to grade it, and they get instant feedback. So if a student gets the answer correct, a piece of the mystery picture will come up. So I got -9 plus 13. So we're going to go over our rules, and I'm going to ask myself, all right, same sign, no, different signs, yes. Okay, I think it's 4. Maybe. Okay, bam. All right, so piece of the picture came up. Okay, so if they get it wrong, you will see nothing happens. Okay, so if I type in 15, nothing happens. But if I fix it, oops, it's -15. Okay, all right, bam, another piece of the puzzle picks up or comes up. When they are done, this is the full picture. How cute is that? Brittany says, what if students don't have Google account? Can you share the pixel or mystery puzzle? Brittany, yes, you can, because this is made in Google, whatever the Excel version is. So all you have to do is you just go into the file here, and let me see if I remember. Okay, yeah. So you're going to download this as a Microsoft Excel, and then it will work exactly the same. So Google Sheets, thank you. And this is made in Google Sheets. So that's actually really the amazing thing about Google Sheets is just download it as Microsoft Excel and then assign it to your students if you use Microsoft, not Google Classroom, but the Microsoft version of it. So yeah, your students can definitely still use this and it will work exactly the same in Excel. And the last thing I want to show you is actually the pixel art because, and again, that works exactly the same as the mystery, the mystery puzzles. So again, this just looks like a boring old Excel sheet with like all these squares, right? Again, self-correcting and instant feedback. So here, these problems are a little bit more advanced, right? So I got 9 minus -3 plus 2 minus 7. So I got to take this into multiple steps here. 9 minus -3. Okay, so keep at opposite here. So it's going to be a 12 plus 12 is 14. 14 minus 7 is 7, I think. Okay, so you can see I got it right. So pieces of this is starting to come up, and I'm like, what is it? And every time I assign a pixel art activity, the kids are so beyond engaged because they have to know. They have to know what the picture is. Okay, so negative. So let's just say I got this one wrong. I'm just going to make up a number here. We'll say 9. Okay, bam, nothing happens, right? So -11 minus 2 is -13, 14. -14 is going to be -11. Oh, I got that wrong. What is it? Wait, 12, 13. Oh, -10. Okay, so look at. I mean, I'm right there with the kids, right? -10. So bam, more of the picture comes up. And when they are all done, because they will not be able to stop until they finish, like they're just gonna wanna keep going, it will come up with an awesome pizza, right? So they're gonna be like, wait, this definitely is a lion. I bet it's a lion. Or like you'll start to hear the chatter of what it possibly could be. Okay, so let me take you back to finish up with the slides here. Okay, so those are some of my favorite digital activities. And my last activity that I love to do is an escape room. Like this is all printable. You put them around the room. These are pictures of my students doing an escape room, and it's so, so fun. We also do have digital escape rooms, but this particular one is specifically for integers. If you want all of these activities, you can grab it today. It's $27. It's going to be available until tomorrow only. You can scan this QR code or go to bit.ly/integer bundle if you would like to grab it. It's like I said, it's only 27 bucks. Let me see if I can put this in the chat for you if that is helpful. So that is if you want to grab the bundle, it's $27. You get over 35 resources, all the resources that I showed you and more, because you are going to get not only adding and subtracting integers in the bundle, but also multiplying and dividing, because once you're done with adding and subtracting, we got to move on to multiplying and dividing. So you get everything in there, and there's PowerPoints, there's practice problems, there's task cards, there's printable mazes, there's digital mazes, like all the things. Okay, so I did not forget that you can be able to grab your freebie. So you're going to be able to get the integers reference sheet right here. I'm going to go ahead and copy that link and put them in the chat right here. And this is only for you for being here. You will not find this link anywhere else. So once I log off, it's gone. So, just grab it. I'm so happy that you're going to be able to get it. And you're also going to get a ton of bonuses with the integers bundle as well. Normally the integers bundle is like $250, but it's 80% off. It's 27 bucks. Use that QR code. Use the link that I just shared in the chat as well. And it's an amazing, amazing deal. I just wanted to be able to put something together so that now that you have all the rules, now that you have all of these, skills and the ability to move teaching, adding, subtracting integers, I wanted to be able to give you something that you can not only use with these teaching strategies, but just to be able to like give to your students right away. Like give them the teaching strategy, go through the strategies, and then bam, here are all the resources that you could use to teach this. So that's it for me. That's it. If you have any other questions, let me know in the chat before before we close out. Is there a link for the webinar? The webinar link, there will be a link for a replay that will be available until tomorrow. And otherwise, that's the only link I have. I don't have any other links. Again, thank you so much. Thank you, Amy. Thank you, Vicky. Thank you, Amber. Thank you, Lindsay. I'm so, so happy that you found this to be valuable. Susan says, thank you so much, Kathy. I definitely attend another free webinars. Susan, we actually do, Susan, and to anyone else who might be wondering, every summer we put on a summit. It's called the Middle School Math Summit. So it's coming again in July. And so look out for that. If you are on the email list, I will definitely be sending you information about it. And it's just free. It's a free PD, 3 days during the summer. So Vicky says, do you monitor your email or is it someone else? I need to ask about the order to teach concepts. I have no curriculum. I monitor my own email. So yeah, feel free to reach out to me and we can definitely chat about it. I'm happy to help. So yeah, again, if you are already a member of the Prealgebra Teachers Math membership, all of these resources are already in there for you. But if you're not and you just wanted to grab this, it's an amazing $27. It's less than it's like 75 cents a resource. Otherwise you'd be paying $250 like per resource. And like nobody wants to do that. So grab it. It's $27. And Charlene, thank you so much. Thank you for being here. And thank you to all of you for being here. I so appreciate you. And have a wonderful rest of your Tuesday. Thank you again for joining me, and I will see you next time. Bye for now.